Hello, and welcome back. Today, we are going to take all the structured, logical skills we have been building and learn how to apply them at a professional scale. This is the final, capstone skill for your pathway. We are tackling S55, analyze in detail large datasets, using a range of industry-standard tools and data analysis methods. This skill is about preparing you for the reality of data in a modern business. I want you to think of it like this. So far, we have been learning how to be an expert sailor on a calm, predictable pond. That pond is like a perfectly clean spreadsheet. But the real world of data is a vast ocean. To navigate that ocean, you need a bigger, stronger boat, and you need to learn how to use professional-grade navigation tools. The principles of sailing are the same, but the tools and the scale are completely different. My goal today is to give you a clear, structured guide to those professional tools, so you can feel just as calm and confident on the ocean as you do on the pond. Let's use my scaffold and ascend method to break this skill down into a logical structure. This is all about upgrading your toolkit. First, the phrase, analyze in detail large datasets. The idea of a large dataset can feel vague and intimidating. I am going to give you a simple, three-part definition, the 3Vs, that will give you a clear, rule-based way to identify when you are dealing with one. Next, using a range of industry-standard tools. This is the core of the skill. It is about knowing the limitations of the tools you use now, like spreadsheets, and having a clear, logical decision process for when you need to step up to a more powerful, professional tool like a database or a programming language. Finally, and data analysis methods. This doesn't mean you have to learn a whole new way of analyzing data. It means you will apply the same structured thinking we have already discussed, but you will learn the specific techniques that make those methods efficient enough to work on millions or even billions of rows of data. It is about making your existing skills scalable. Let's focus on why this skill is so critical for your career. This is what the industry expects from a professional data analyst. First, it is the industry benchmark. In today's world, the ability to work with data that is too big for a spreadsheet is the fundamental difference between an office worker and a professional data analyst. Being able to confidently write a SQL query against a large database is the baseline skill that employers will look for. Second, it unlocks much deeper insights. When you can work with the entire dataset, all million customers, not just a small sample, the patterns you find are more reliable and you can discover much more subtle relationships. This skill is what allows you to move from analyzing a sample to analyzing the truth. Finally, I want you to see this as your structured career path. The progression of tools we are about to discuss is a clear ladder for your technical development. You start by mastering spreadsheets. You get your first data analyst job by mastering SQL. You become a senior analyst by mastering a programming language. And you become a data science lead by mastering cloud platforms. It is a clear, logical, and predictable path for you to follow. So, what do we mean by a large dataset? I want to give you a simple, rule-based definition you can use. A dataset is large if it meets any one of these three conditions, which are known as the 3 versus first volume. This is the most common one. It is about the sheer size of the data. The rule for you is simple. If you try to open the dataset in your spreadsheet software and it either crashes, freezes, or becomes unusably slow, you have a volume problem. This typically happens when you have more than 1 million rows. Second, velocity. This is about the speed at which the data is arriving. The rule is, if the data is being delivered as a continuous, real-time stream, rather than a single file that you get once a day or once a week, you have a velocity problem. Think of a live feed of website clicks versus a monthly sales report. Third, variety. This is about the complexity and messiness of the data. The rule is, if the data is not already in a neat, structured format of rows and columns, you have a variety problem. This applies to things like nested JSON files from an API, a folder full of unstructured text from customer emails, or a mix of different file types. If your data meets any of these three rules, you know you need to step up from your basic tools. Okay, so you have identified that your dataset has a volume problem. It is too big for your desktop. What is the first, most logical step up in your toolkit? It is the database, and your tool to command it is SQL. The principle here is the most important concept in scalable analysis. Don't move the mountain to find the rock. A common mistake is to try and pull all 10 million rows of sales data from the database onto your own laptop so you can filter it there. Your laptop will crash. The professional method is to use the power of the database server itself. You write a smart SQL query. You use the where clause to filter the data down to only the rows you need. You use functions like group by and AVG to pre-calculate the summaries you need. The database does all the hard work on its powerful servers, and it only sends the final, small, aggregated result back to you. This is the most fundamental technique for dealing with large volumes of structured data. Now, what if your problem isn't just volume, but variety? You have been given a folder with 1,000 messy JSON files from an API, or you need to extract information from unstructured text. A database in SQL can't help you here, because the data doesn't fit into neat rows and columns. This is when you climb to the next rung on the ladder, a programming language, and for a data analyst, that almost always means Python. The principle is simple. When the data doesn't have a predefined structure, you need the power of a programming language to create a script that can understand and impose a structure on it. The standard method is to use Python along with its most powerful data analysis library, pandas. You would write a script that can, for example, open every single JSON file in a folder, navigate through its complex nested structure to find the specific pieces of information you need, and then pull them out and assemble them into a single, clean, structured table that we call a pandas data frame. This is your tool for taming the chaos of messy, semi-structured data. Finally, what happens when you face a problem of such massive scale that even a single powerful database server can't handle it? This is when you climb to the top rung of our ladder, cloud platforms. The principle here is that instead of trying to solve a massive data problem on one computer, you can rent the power of thousands of computers from a cloud provider and have them all work on the problem at the same time. The method for you as an analyst is actually quite straightforward. First, your massive dataset is uploaded to a cloud storage service. Then, you use a special cloud tool to analyze it. The amazing thing is that you still interact with it using the same SQL you already know. You write a standard SQL query, but when you press Run, the cloud platform automatically sends that query to hundreds or even thousands of computers, which all work in parallel to scan the data and bring you back the answer, often in just a few seconds. This is how modern companies analyze petabyte-scale datasets. Let's put this all together with a realistic, large-scale project example. A manager gives you a hard drive containing 500 gigabytes of raw website clickstream data and asks you to analyze it. First, you apply your structured thinking and identify the problem. You know you can't open a 500 GB file in a spreadsheet, so you have a volume problem. You inspect the files and see they're in a complex, nested JSON format, so you also have a variety problem. Second, you select your tools using a ladder. Because of the high variety, you know you will need Python. Because of the high volume, you know you will probably need a cloud platform. Third, you define your method. It is a clear, three-step process. Step 1, I will use a Python script on a powerful machine to process all the raw, messy JSON files and turn them into a single, clean, structured dataset. Step 2, I will upload this clean dataset to our cloud storage. Step 3, I will then use the Cloud Query tool to run my SQL analysis on this massive dataset to answer the business questions. You have taken a huge, intimidating problem and broken it down into a logical, manageable, and professional plan. For your portfolio, S55 is a great opportunity to show your technical maturity. Use the STARR method. Situation: I needed to analyze customer transaction history for the last 5 years. Task: the dataset contained over 10 million rows, which was too large for our standard spreadsheet software. Action: I demonstrated S55. I identified this as a volume problem. Instead of downloading the raw data, I wrote a SQL query to filter the records by region and aggregate the sales figures by month directly on the server. Result: I produced a manageable, lightweight report showing key trends without crashing any systems. Reflection: I learned that for large datasets, server-side processing is essential for efficiency and performance. In your major project, S55 should appear in your Methodology or Technical Approach section. Show evidence of your scalable thinking. Include screenshots of the SQL code or Python scripts you use to handle large files. Explicitly justify your choices. Write: I chose to use Python for this analysis because the source data was unstructured, and standard SQL tools could not pass the format. This proves you are making deliberate, professional decisions. To conclude, mastering S55 makes you a resourceful analyst. It gives you the confidence that no matter how big or messy the data gets, you have the logical toolkit, databases, programming, and cloud to handle it. Thank you for your focus. Thank you so much for joining me today. I hope you now feel more confident in mastering this topic. If you found value in this session, I have a small favor to ask. Please hit that subscribe button, give this video a like, and follow our channel. It really means a lot to me and helps the algorithm show these lessons to other apprentices, just like you, who need support. Don't forget, you can download today's slides and the full transcript at www.mentorinai.com EPA Hub. While you are there, check out our mock interview and portfolio review services to make sure you are fully ready for your EPA. See you in the next video. Keep learning.